Okay, so we're going to do 5, 5. And there are, I believe, many different parts. Not many different, but like 2, maybe 3. Anyway, this first part is talking about domains, which we did before. I forget what chapter it was, but it was chapter 4 actually. So there were some restrictions when you find the domain. One was if you have a fraction, your denominator, I'll just abbreviate there, cannot equal 0. The second thing is if you have an even root index. If you have an even root index, then the stuff underneath must be greater than or equal to 0. And the third thing was that if we had a fraction and an even root radical in the denominator, then you do greater than 0. So I'm going to cross off some of these. I'm going to cross off, I don't know, number 2, number 4. That should be good. I'll just cross off those 2. Now we have 2 new ones, 7 and 8. So before I get to those, let's go ahead and answer the questions on the rest. So on number 1, I have an even root radical, so it's like number 2. So the stuff underneath, which is 36 minus x squared, must be greater than or equal to 0. So from there, I'm going to work backwards and solve for x. From here, I have to divide a negative, so everything's going to change. So x squared is less than or equal to 36. Then I got to take the square root. But remember, if I am taking, or if I have an x squared, then in my answer I should have this as an answer. So this is my answer to number 1. So this is just a review until I get to the 2 new ones down here. Okay, number 3, I have a fraction. So this one's like number 1. So since it's number 1, my denominator, which is x plus 3, cannot equal 0. So if I work backwards, I get x is not equal to negative 3. So that is my answer to number 3. Okay, number 5. So looks like I have an exponent. X is in the exponent. And I don't have anything over here that talks about that. So if it's not on my list, it's all reals. This one, same thing. Yes, I have a fraction, but my variable is not in the fraction. So this is all reals as well because x is in the exponent. So if x is in the exponent, it's all reals. So these 2 are kind of new as well because you'll see these on the homework. Okay, now these 2 are definitely new. So I'm going to add this to my list. So if you have a log or a natural log, then the argument, which is the stuff in parentheses, must be greater than 0. Because if you recall, the argument cannot be 0 or negative. Okay, so that means that on number 7, the argument, which is 16 minus x squared, must be greater than 0. So from there, I'm going to work backwards and get x by itself. Got to divide by negative 1, so if I do that, my signs are going to flip. And then I got to take the square root. And then since I had an x squared in my question, I have to have an absolute value in my answer. So this is my answer to number 7. So the only difference is that I'm adding a log and a natural log to my set of rules here, and it can't be greater, or it has to be greater than 0. Okay, number 8. This right here is my argument. This has nothing to do with it because it's not in parentheses. So 5x plus 15 must be greater than 0. And then we're going to work backwards. We're going to subtract over the 15, divide over the 5. I don't have to put an absolute value because there wasn't an x squared, so just this is my answer. Okay, so that is domains. Okay, so, all right, so the next section, there's actually 3 sections. I think I mentioned that before. So I'm going to circle the questions that are alike. So I'm going to use a different color. And actually, I'm going to write them down as well. So number 9, this might be helpful. Number 9, 14, 16, and 20 are all alike. Then we've got 10, 13, and 19 are all alike. And then we've got 11, 12, 15, 17, and 18 are all alike. Okay, so now that I have them broken up, let's go ahead and see how to do these problems. Okay, so the first thing you want to do, it says so right here, the first step is always to change to exponential form. So we're going to do that. So in number 9, I'm going to rewrite this as 2 to the 3rd power equals x. If you recall, whatever is by itself, that's the exponent. Before, there was nothing there, so we didn't know what the exponent was, but now we do. So it's 2 to the 3rd equals x. So that means my answer is 8. Okay, let's look at the other 3 that are similar. All right, number 14, I'm going to do next. So I'm going to rewrite this in exponential form. So I have 100 to the -3 power equals x. The number that's by itself is the exponent. Now, we cannot use a calculator on these. So what we're going to have to do is get rid of our negative exponent first. So to do that, I'm going to flip my base, so that becomes 1 over 100, and then my exponent changes to a positive. Okay, so now I'm going to have to rewrite this as a radical, which we have done before. So 1 over 100 goes under the radical, the denominator goes in front, the numerator goes in the back. All right, so I got to figure out what number squared is 1. That's 1. What number squared is 100? That is 10. And now I'm going to cube both of those numbers. 1 to the 3rd power is 1, and 10 to the 3rd power is 1,000. So that is my answer to 14. Okay. Let's see which one was next. 16. Okay, 16. All right, so the first thing I want to do is rewrite my problem in exponential form. So 17 to the 0 power equals x. Well, anything to the 0 power is 1. So 1 is my answer. Okay, and then the last one that's like the rest that we just did is 20. Okay, so I'm going to, first of all, rewrite that in exponential form. So 16 to the 3/4 equal x. Now the reason these are all similar, these 4 that I've done so far, is that x ends up equaling the argument, or x is the argument. We don't know, if I rewrite it in exponential form, I don't know what the answer is. So it's always going to be equal to x on the ones I just did. From here, I'm going to rewrite this in radical form, because again, I can't use my calculator. So I'm trying to figure out what number to the 4th power is 16. That would be 2. And then I take 2 cubed, which is 8. So 8 is my answer. Okay, so those are all similar. Okay, let's go back to the next ones. So again, the ones that I just did, when I rewrite them in exponential form, x is going to be, it's going to equal x. That's why they were all similar. These three, x are going to be in a different spot. X looks like is the base. But no matter what, you're going to rewrite them in exponential form. So this is going to be x to the 4th power equals 81. So I just got to guess what number to the 4th power is 81. It's 3. So 3 is my answer. Okay, 13 and 19. And the reason they're the same is because my variable is the base this time. So on this one, if I rewrite this, it's going to be a to the 1/2 power equals 3. And I just got to think about it. The 1/2 power, that's the same thing as the square root. So what number, or the square root of what number is 3? Well, my answer must be 9. And then we said number 19. Okay. So if I rewrite that, it's going to be x to the 2/3 equals 16. Now this one I can't really think about it, or maybe you could, I don't know, but you could also move this over to here, but if you move this over to here, you have to do the reciprocal. So I gotta figure out what is 16 to the 3/2 power. So if you can't figure this out just by looking at it, you can move your exponent over to here by just doing the reciprocal. And then you want to rewrite it because it's easier to figure out if it's in radical form, probably. All right, so the square root of 16 is 4, and then 4 cubed is 64. Okay. All right, so that takes care of those. And then the rest, it looks like x is going to be by itself. That's how those are all similar. Okay. So I'm going to rewrite those in exponential form. No matter what kind of problem that is, that's what you always want to do first. So I'm going to write this as 4 to the x equals 16. And then you just think about it. What number, or 4 to what power is 16? It's 2. Okay, number 12. 125 to what power is 25? Okay, this one's a little bit more challenging because you just can't think about it. Or maybe you could, I don't know. So what you need to do is, if they have the same base, it might be easier to figure out, because if the bases are the same, the exponents are also the same. So these are both powers of 5. So I can change 125 to 5 cubed, and then I still have an x there. And then 25 I'm going to change to 5 squared. Okay. So I really don't need those parentheses there. I just put those there to show you that I changed the 125 and the 25. So really I have that. So if my bases are the same, my exponents need to equal each other as well. So what I'm going to do is I'm going to set my exponents equal to each other and then solve for x. So x must be 2/3, which makes sense, because if I take 125 to the 2/3 power and I rewrite that in radical form, the cube root of 125 is 5, and then 5 squared is 25. So sometimes you can think about it right off the bat, other times you have to get the same base and go from there. Okay, I'm gonna skip down to 17 and 18 because those are very much like 12, and then I'll go to 15. Okay, so 17, I got 27 to some power equals 81. So these are both powers of 3. So you have to know your powers. So if you have your blue paper from last chapter, that might actually come in handy. So this is going to be 3 cubed, and then you have an x there, and this is 3 to the 4th. Now that the bases are the same, you can set your exponents equal to each other and solve for x. So x is going to be 4/3 on that one. Okay, 18. So let's rewrite it first. So 512 to the x power equals 128. So if you look at your blue exponent paper, they're both powers of 2. This is 2 to the 9th, and this is 2 to the 7th. So 2 to the 9 with an x, and this is 2 to the 7th. Now that your bases are the same, you can set your exponents equal to each other and solve for x. So x is going to be 7/9. Okay, so then we have one more that has x by itself, which is going to become the exponent. So this is going to be 4 to the x equals 1/64. So since this is a fraction, that must mean my exponent is negative. So since 4 to the 3rd power is 64, 4 to the negative 3rd power is 1/64. All right, there's a lot of stuff going on here, but if you just rewrite in exponential form first, I mean, you should know hopefully what to do from there. But the key is rewrite them in exponential form first. Okay, so that brings me to the third part of your notes. This is when you have logs on both sides. And let's see if I can mark off any. Maybe 25. Maybe 23. I'll cross off 23 and 25. Okay, so if you have logs on both sides, this one's actually pretty easy to solve because once you condense, you can just cancel some things out. And here are our steps right here. So the first thing I want to do is make sure I condense each side, meaning I should have one log on each side. So this one just has one log, so this side's okay. The right side, I have 2 logs, so I need to condense that first. So this addition sign means I'm going to multiply the 2 arguments together. So this is going to become log base 3, 20. Okay, so now that I have each side condensed, I'm going to set the arguments equal to each other, which means the logs can just go away. I am left with 4z equals 20. And now it's just a basic equation. Z equals 5. And then that's my answer. So we just solved. It says to check. So if I were to go back and substitute 5, and for z, this result should be a positive number, which it is. It's 20. Okay, 22. So it looks like the right or the left side is not condensed because this 3 should really be an exponent. So I'm going to make that be a 3 up there. Okay, so now I can cross off the logs. I'm left with 4 cubed equals m. Well, now I just got to figure out what 4 cubed is, and then that's my answer, which is 64. Okay, and we crossed off 23. That brings us to 24. Okay, so at first I probably need to change that 3 to an exponent. Okay, this addition sign means to multiply. So I'm going to take 2 cubed, which is 8, times x, which is 8x. So this becomes log base 5, 8x. The right side is already condensed. Okay, from there I can cross off the logs. I am left with 8x equals 24, and now it's just a basic equation. So x equals 3. Okay, we got one more on the back, number 26. Okay, so the first thing I want to do is probably, let's look at the left side first. So I'm going to change this 1/2 to an exponent since it's down in front. So the left side is log base 5x to the 1/2. Okay, now I got to do something. So if you're not sure what to do next, just do the parentheses first. So let's look at this. Let me bring everything else down first. Log base 524 minus 3, and I'm going to do what's in parentheses now. So this means to divide the 6 and the 3. That's going to be 2. So now I have log base 5, 2. Okay, now I want to see if I can figure this out. I got to see if I can figure out 5 to some power is 2. Well, that doesn't work. So since I can't simplify that more, I now have to make this an exponent. So if this doesn't simplify, then you have no other option than to make that an exponent. So I'm going to make that 2 cubed. Okay, so now I'm going to bring down the left side. Okay, so this becomes 8. 2 cubed is 8. So this 24 and this 8, I'm going to divide because that's what that subtraction sign means to do. So I'm going to have log base 5, 24 divided by 8, which is 3. Okay, sorry, I got distracted. All right, so now I am going to cross off the logs. I am left with x to the 1/2 equals 3. So if you remember, this 1/2 is the same thing as the square root. So I'm trying to figure out the square root of what number is 3. That would be 9. Okay, now the homework is to do 5-5. However, there are some questions on 5-5 that you're probably not going to know what to do. So I'm going to help you set those up. Let me get a fresh piece of paper. So if you look at homework 5-5, 19, 20, and 21, we didn't really have anything like that in the notes. So I'm going to help you set those up right now. So if you want to get out a piece of paper, then maybe you should do that. And I'm going to get a piece of paper too. Okay, I'm back. All right, let's see. So number 19, I circled the ones that were kind of different. So I'm just going to help you maybe set these up. So number 19, the first thing I want to do is condense. So this addition sign means to multiply the two arguments. And I don't have any exponents, so all I'm going to do is do log, and I'm going to take x times 3x minus 5, and that's equal to log 2. All right, that's what you're going to do first. The next thing you're going to do is cross off the logs because now they're condensed. And then what you're going to do is probably distribute that x to get 3x squared minus 5x equals 2. Now you can't really work backwards. You're going to have to, since you have an x squared and an x, you're going to have to probably factor that. Let me see something really quick. Yeah, you're going to have to factor that and then solve for x that way. So you can finish it from there. So factor, and then solve. Okay, that takes care of that one. Now 20 and 21 are similar. So I'm just going to do one of those, but make note that 20 and 21 are very similar. So let me do number 20. So I'm going to set up 20 and then you'll be able to do 21. Okay, this time this means to divide. I don't have any exponents, I don't have any numbers in front. So I'm going to have log base 2 x plus 5 divided by x minus 1 equals log base 2, 3. Okay, so the logs are on both sides. Those are going to cross off. And what I'm left with here is well, I could make it a proportion. So I could make this 3 over 1 if I wanted to. So let me rewrite what we got here. So I have x plus 5 over x minus 1 equals 3 over 1. So from there, I'm just going to cross multiply and then work backwards. Cross multiply, and then you're going to solve for x. And then 21 is the same way. So now hopefully you should be fine.